Marina Otero, she's an architect and a theorist who's based here in Rotterdam. She is also working at the head of the Social Design Masters at the Design Academy in Eindhoven, and was until recently also the research director of the New Institute, also here in Rotterdam. And over the past year, Marina has curated and worked on a whole range of projects that kind of deal with the impact of technology on our life, but also the impact that technology has on our urban surroundings and our physical surrounding. So some of the projects that she's been working on were automated landscape, focusing on the emerging architectures of automated labor, on burnout, which was about extortion on a planetary scale, and lithium, quite recently, about the applications and the dependency and impact of the element lithium in both medicines and its medical application, but also especially in the way that it's used in our technology and how it fuels the energy transition. And the direct reason to invite Marina to curate this first series of lectures in Back to School With was that she recently won the prestigious Harvard GSD Real Right Prize on her proposal, Future Storage Architectures to Host the Metaverse, examining architecture paradigms for storing data and how to reimagine digital infrastructures, how they could meet the unprecedented demands facing the world today. A lot of words. You can explain it much better, and you will in a little while. And that's also what we call this series. So it's really one-on-one part of your, or how I would like to see it, part of your research project. As I explained, we started a couple of weeks ago with the first series. The first lecture that was about the design of data storage. We had Ippolito Pestellini here. Today we will talk about the technology of data storage, for which Marina actually invited Christopher Schlaeffer, and you will introduce him further later on. And on the when is it? The 22nd of November, we will wrap up this series with a third evening, and then we will talk about the future of data storage, and Monica Seyfried will be here talking about also the storage of data in DNA of plants. And we have also the pre-book launch of Asset Clouds, which was a research project also about the architecture and design of data centers. So that will be in a couple of weeks. I wish you a really nice evening today, and I would like to give the floor to Marina.
It's only for the recording. Okay. Well, thank you so much, Mike, for the introduction and also for the invitation, and to Wouter and Michelle and all the Independent School for the City. And thank you all of you for being here today. I see a lot of friends, and I'm very grateful for being today with us. So for some of you, this will be a little bit of a repetition, because I'm going to make a quick summary of what we discussed last week. So some of you have been here before. For some of you, this was the first lecture. So I'm going to do a little bit of an introduction, and then I will invite Christopher to give a keynote lecture. So just to give a little bit of a context and situate the research here, the question of data center is something that is in the press. For instance, recently, one of the big meta hyperscale data centers in one town in the Netherlands was banned because it was enduring a lot of protests by local population. And as a result, the government decided to have a ban on data storage, hyperscale data storages, for a while, until the industry, together with the government, figure out some legislation and ways in which these infrastructures are not consuming so much energy, especially in a moment of energy crisis or energy shortages, but also emitting CO2 and consuming water. these questions are more and more discussed in communities around the world. So it's not only this particular community in the Netherlands, but also others in Ireland, in Singapore, in Chile, and many other places that are having the same concerns. So therefore, that's what we are here today to discuss data storage and data technologies and what they could be the future that we have for them or we can find for them. Yeah, so I was also talking about how we often see these surveys and graphs that point to a big growth on both data storage, the necessities, and also data consumption and production. And obviously, some of them, are only forecasts, but in these cases, you see that it's 2025, so it's already there. And we see how there is a very important growth in data storage need in the world. That's also the reason why the industry is one of, an important industry that has been growing in the last years. In this graph, what it shows is that there is a potential, something that is called a potential zone of insufficiency, meaning that the consumption or production of data is bigger than the capacity of data centers to store this data. So then there's a conflict between the infrastructures we have and the data we produce and we consume. So what does it mean? There is a shortage of data storage, and we can say we produce more, but we know already that that causes a lot of struggles, or we find other mediums for data storage, or we change our data consumption patterns. So all of them are on the table. But what is evident is these dreams we have, and more than dreams, about the a smart city, the Internet of Things, and more recently the introduction of the development of the metaverse. They are actually dependent on those infrastructures such as data centers. So if we want to have something like this, a hyper-connected city, that needs a lot of data flows and that needs data storage. And yeah, some information. I have to say that these numbers always vary depending on the the surveys and the statistics you find. So how much actually data storage data centers emit, and sometimes they put it in relation to the industry, like airplane industry. So it's quite a lot. It's 2-3%, and in some cases there are predictions that will be almost like 15%. But we are always predicting. But my main question was, okay, there's a situation right now, and we are dreaming or thinking about the development of the data and digital industry, especially in ideas like the metaverse that create a parallel world that needs continuous flow of information, and that information needs to have a place to be stored and processed and circulated. So if we already are stretching the infrastructure, how come we are able to develop something like that? So for me, many times I'm asked, what is the metaverse? And my counter question is, how do you store it? And this is the project that is the proposal I made for Harvard. And the idea is that I will be traveling to different places, looking into current developments that are perhaps pointing to ideas of where the industry will go, both in terms of more technical or technological developments, are also eco-social developments. But it's not something like many people is thinking on those questions. For instance, there is an European code of conduct connected to data centers. So there is already legislation that is trying to, create a framework for these developments. And what we discussed last week with Hipólito was that this is generally how we envision or design a data center, like a series of servers, server racks, and kind of an envelope that allows to maintain certain conditions under which these technologies can work. And apart from some vertical designs, this one is, for instance, in the Netherlands, or some experimentation in facades. That is generally what data owners, data storage owners think that the architects can contribute. There hasn't been like big transformations in the design of data centers. Most of the times in our conversations over the last years, we were always, addressed as architects by the industry to participate in the design of facades, to make these infrastructures a bit more appealing for the surroundings, but not necessarily on how they are organized in the territory and connected to other infrastructures. And that's what people like me think that architecture can do, not alone, obviously, but with other disciplines, reconfigure and redesign these infrastructures in relation to in different scales. But because of the growth of the industry, the need of more space and the controversies and the need to find other solutions for design, many companies, for instance, a real estate company like this one is one of the biggest in the world, has created a division for data storage, data centers. And the same has happened in firms, architectural and engineering firms like ICOM and Arup and others. So something that before was not considered at the core of the architectural profession now is being created and being given visibility and space within those companies as one particular division of innovation. I'm going to just guide you very quickly to some of the places that I want to visit. One is Singapore, because as happened in the Netherlands, they had a ban on data centers 2 years ago. And during that time, they were developing new visions for their design. Some of them are these floating data centers that are powered by these mega solar floating farms. So I'm interested in looking at these models. I'm also interested in underwater data centers. The prototypes were tested in different parts of the world, but China has included this model of data centers in 3 of their provinces in their 5-year plans, which means they are going to be implemented and in a huge scale. Another case is, in particular, it's in Lagos, but I'm interested in the condition of communities in the African continent because most of the data centers, for instance, are located in Marseille because of questions connected to the availability of energy or the unreliability of infrastructures. Many of the data centers that should be in other of these countries are located in the south of France, which is also quite interesting. And I'm interested also in the impact of these infrastructures in local communities, or how local communities had imagined the relation to data centers. For instance, this is a case in Australia where indigenous communities are opening their own data center. And it's not the only case. There is a series of companies who are led by indigenous communities in Australia that are thinking about data storage as an income, like an industry that they can participate, but also as a means to have a say in data governance. So I think for me that's also very important. I'm also traveling to Iceland and the Nordic countries where the availability of sustainable energy or like green energy makes them a very attractive location for data centers. This one, for instance, is in Stockholm, and there's a hybridization. There is data center and nightclub, but also is designed in a way that the excess of heat powers or gives heat to surrounding communities. And obviously, these questions are not as easy as they look like, but we will discuss them perhaps. But yeah, there's this idea of hybrid models and also sharing with existing infrastructures connected to the data centers. What is the downside of this is in many cases, some of the wind farms or solar farms are being constructed in places where there is indigenous communities, in this case, the Sami communities. And they are interfering with some of their cultural heritage and activities of cultural and economic importance, as is the herding of reindeer herding. So there is this idea of like, sustainable energy, but at the same time, it's affecting local communities in what many people call green colonialism. And I'm also interested, I'm traveling there in December to also interview communities and visit some data centers to see the struggles and the problematics between the two. And finally, I'm not talking about all the locations. Chile has a very beautiful history connected to data storage with this device that is called the Kipu, through which, making different nodes in the cores, they were able to hold impressive amount of information. It was developed, used by the Inca Empire. And you can see like it's using some kind of binary code, and this was used to transmit information across the Inca Empire that was stretching through a big part of the territory of the Americas. So this heritage now comes back when there is a new cable that is connecting Chile to Australia and other places like New Zealand, creating or making Chile of a hub. So Chile not only has the history, has the new cable, but also the resources that are serving the data center industry. In this case, lithium. Lithium is one of the main components of batteries that are used in our laptops and phones, but also batteries of data centers. So I'm interested also in the conflicts between our green energy futures as the ones envisioned by Tesla, and the conflicts that happen on the ground in Atacama between the mines and the indigenous communities. Last event, we discussed with Ippolito Pestellini about how data centers could be absolutely banal, ugly, and totally, uninteresting infrastructures, but at the same time are fascinating and relevant places where to, intervene as a designer. So he did a magnificent overview of the questions surrounding data center design. One of the questions that we were discussing at the end was the possibility of decentralized models of data centers, and both Ippolito and I started to have this conversation thanks to Christopher. So that's why I also wanted to involve Christopher in this series, because it was a conversation that we have in the RCA with our students, where Christopher was talking about the difference between hyperscale data centers and decentralized models, and which one eventually will win the battle. It's like we will go to either bigger data centers, almost like huge cities that are data centers, or a model that is much more decentralized, or maybe the two. So that was the way in which we initiated a lot of student-led projects about the possibility of having data centers in our windows, like at the level of the neighborhood. And as Mike said, the last event in the series will be about data storage as a medium. So we have been talking about the architecture, but what happens if we change the medium of storage? For instance, instead of using servers, we use DNA as a medium, and there are others. Then immediately the architecture and the conditions change. So it's a trigger for imagination. That's what is the exercise that we will do in the next talk, together, as Mike said, with the launch of the book Acid Clouds. But after this quick overview, I don't want to take more time, because today we are here to listen to Christopher Schlaeffer. I was practicing with Ina, and then I was like, Ina, she's German. Can you tell me a little bit how to pronounce? And it sounded better when I tried last time. As I said, Christopher has been our guru in many ways, a person that we really are grateful for spending time with us, thinking together. He has a vast experience in the industry of data and telecommunications, not only in having leading positions in Deutsche Telekom and T-Mobile and many other companies. Also, he was involved in bringing the iPhone to the European context, and has been definitely connected to the big developments that we have seen in the last decade. And now he's also creating other companies. For instance, I'm very especially interested in hearing about the contextual platform, internet platform called Love. And in addition, he has been a philanthropist, working also to empower different communities in different aspects from diversity and inclusion, and also having more data literacy in different aspects. But he will talk about that much better than me. So please, Christopher. I will bring your presentation.
Or is the other mic?
This is for recording mainly.
I see. Well, thank you, Marina. Thank you, Mike. Good evening, ladies and gentlemen. I'm really grateful that I can be here with you after the conversations already in the overture of this event. I recognize what an incredible series of interesting people are in this room, and I've already learned a lot. It is my role here not to talk about architecture so much, because I'm not an architect. I'm an economist and a philosopher by training, but I'm a technologist by profession. And I would love to talk you through the seemingly dry topic of technology of data storage, but you will see that it's actually a very, far-reaching thing. And of course, this data thing, we debate that so much since decades already, and how data explodes. There are all these numbers, like for instance, 5 billion photos and videos posted on Snapchat every day, or we are sending, because we are a bit older than the Snapchat generation, 333 billion emails per day, right? This is what we do nowadays as a societal habit. So that produces, of course, data out there. A lot of that is real garbage, but a lot of that, like Sir Tim Berners-Lee said, is really precious, right? It is our data, it's reflecting our lives, it's very personal, it's a mirror of our evolution of human beings and our families and our friendships and our know-how and all of that. And that is why we need to take that question very seriously. And of course, the internet age in which we live in, first of all, has to debate the user perspective before we come even to technology. What do users out there do? We know it all in a way, but let's spend a little bit of time structuring that, what is actually evolving in terms of megatrends. This is still a young phenomenon. I was 4 weeks ago sitting side by side with Sir Tim Berners-Lee at a dinner in the National Gallery, and it is only 1989, right, that the first connection was created by him. It is not so long ago, 33 years, and I was sitting in the National Gallery and with all these Caravaggios and Titians, etc. on the wall, and I actually recognized this man beside me has created the biggest cultural revolution of mankind, much bigger than even my beloved Rubenses and Raphaels and Michelangelos on the wall. It is really, I think, the cultural evolution of mankind which we are talking about. Now, the user perspective is first of all this stupid slogan of mobile first, but in a way it was correct, right? In 2007 and 2008, there was a change which shaped the way we consume the internet today. And there was, of course, this man on the left-hand side after 5 years of a totally secretive project on the 9th of January 2007 at Macworld, coming out with something where he said it's not only a music player or an internet device, it's also a phone, and he called that iPhone. That little device, and that becomes interesting also for data storage, had a computing power which was larger than the entire Apollo mission of NASA in 1969 in that single phone. And I mean both in space and on Earth. The entire NASA computing capacity was smaller than in this little phone. And of course, computing power and data storage are very related, because we're going to talk about how you process and store data, and they depend a bit on each other. So this was very significant. And he had that beautiful phone, which we all know and we all most likely have in the Western world. But the real opener for the mobile internet actually was the Android operating system. You see me here a little younger with Larry Page and Sergey Brin launching the Android operating system in a New York subway station. I actually started that on the 19th September 2008, the press conference, and Larry and Sergey were roller skating through New York with a poster on their back. Android, this frog or robot, was on there, and they joined me in this press conference, and here was Andy Rubin on the left, the real founder of the Android operating system. And here we were with an ugly phone, not as beautiful as the iPhone, only 4 apps at that time, and I was quite nervous because I didn't know whether this would ever take off. I think history then told us it was really transformative, right, for mankind. But this was the mobile internet, and that is how we use the internet still today. That is our form factor. It will not prevail. It will go away over the decades. We'll not carry mobile phones in 50 years from here. But today it is the defining element. And what we knew quite quickly after these 2 events in 2007 and 2008, that at least the world in which I grew up in the 1980s with the Macs, but predominantly with Windows and Intel, Wintel as the dominant oligopoly, would have been broken. What you see here in a rather complicated chart is the kind of market share of operating systems in the world, somehow from 1975 to 2011, 3 or 4 years after the launch of iPhone and Android. And you see that this big blue area was Wintel, that was Microsoft, and that was Intel, and that operating system dominated everything. But only with launching Apple and Android, we already saw the curve, how mobile computing systems would eradicate the monopoly of Microsoft and Intel and basically dominate computing. And if we talk about computers today, of course, we're not talking about PCs or mainframes, we're talking about mobile phones and increasingly even smaller devices like sensors and actors in a certain degree. So operating systems totally changed. And the real change around that was the opening up of operating systems, because the Microsoft operating system was not an open operating system, right? You had to be a licensee in that regard. But now there was an ecosystem which was still proprietary, I would say, in the case of Apple with the App Store, but much more open in the case of Android, and really inviting developers around the world to unleash their creativity and develop applications for these operating systems and the facilities we started to call app stores or play stores in 2007 and 2008. So this is kind of what happened. And it led to, of course, a fact of today, it's just a current number, 63% of the global population are on a computing system today connected to the internet. There is even more computers out there, kind of 6.3 billion computing devices are out there. Not all of them are connected. But now we are, in 2022 at 5 billion internet users with computing devices, predominantly, as I said, mobile phones, and that is 63% of the global population. We are adding around 500,000 people every day to the internet and connection, so this is not stopping, and we will definitely have more, connected devices than people are on Earth very, very soon, because there is also other phenomena like the Internet of Things connecting out there, and this is where we are. And that leads to, in a banal way, what we are doing on mobile phones. I'm not very interested in that chart, but it's nevertheless, I think, interesting to spend a minute on what, and this is the newest data, it's always has a certain lead time. First quarter this year is the newest data which is available. In terms of monthly active users, that's a league table from 1 to 10. The top 10 mobile applications still start with good old Facebook, which is of course in decline, and it's the dinosaur, and it's being even within Meta being subsidized or replaced by things like Instagram, but that's there. And then it's WhatsApp with a typo, Instagram, Facebook Messenger, TikTok, Amazon, Telegram, Twitter, Spotify, Netflix. We know all of these names. These are today's household names in the Western society, and that is by what users use. It's kind of interesting that the downloads look different, because there's new contenders coming up, and in 5 years they will be on the left-hand side, because Instagram, of course, is overtaking Facebook. Even within Meta, TikTok is challenging the Western world. Silicon Valley, the first time, has a debate about regulatorily banning an Asian internet platform since half a year. Very vocal, even Silicon Valley CEO said this needs to be banned because there's a direct access of the Communist Party to the TikTok data, which is the data of our next global generation on their platform. Then there's still Facebook, but then there's a few other names which are new, right? Like Shopee, a Singapore-based e-commerce platform, which is on the mobile phone bigger than Amazon or other, Chinese platforms. It's a originally consumer-to-consumer platform. It's now business-to-consumer. It's very prevalent across Asia, but we would not have heard of it. So that's interesting. And if you go to consumer spend, then there's a lot of things we don't know because we are becoming too small in the Western world for monetization. There's a lot of Asian contenders which are winning it. TikTok is indeed the mobile application with the highest consumer spend globally today, has overtaken anybody. Then there's YouTube, Tinder, Disney Plus, a phenomenal success in the shortest time, right? After Netflix has already been out there, etc., in a very short time with their content assets, Disney has been able to overtake. And another few video sites, Tencent Video is also there. Google One is Google Storage, here we're in data storage. So you see a consumer phenomenon firing really a data storage model where consumers pay $1 or $2 or euro a month to store their data, and Google is so big. And then there's Picoma, IQE, and QQ Music, which are Asian models, which are basically YouTube, so music things. In the case of Picoma, it's simply a bit of Korean and Japanese reading of comic strips, and it's monetizing brutally, right? It's in the top 10 league out there, and something like QQ Music is a joint venture where Spotify is invested. It's a rare case where a Western company still is invested in Asia, whilst a company like Tencent is very much invested on the Western side with that. So this is the state of affairs in what we as consumers do. But of course, this is not the internet, because if this was the internet, the biggest companies would be this. But the biggest companies are still these. It is still Apple, and that is, of course, after a total stock exchange crash. These numbers have been almost twice as high in most cases, just 6-7 months ago. But if you look at the world's 10 largest companies by market capitalization, you do see that Apple is still leading the pack. Oil is coming back, like in the 1970s. It's very interesting, like in our energy crisis. There were no oil players there just a year ago, but they're coming back and they're having a revival. But then there's Microsoft, Alphabet, Amazon, Tesla, and they did not own the biggest mobile apps. Some of these companies, Microsoft, Alphabet, and Amazon, own the data infrastructure of the world. And that's why I'm showing this chart, because there is something behind the original core business of these companies, being an e-commerce platform in the case of Amazon, and then the foundation of Amazon Web Services, AWS abbreviated, and Google, they're coming from search, and they did Android, and they have YouTube, acquired in 2005, but they're becoming a major player in data infrastructure. And of course, the whole revival story of Microsoft is not because their old consumer business is thriving so much, but because they have entered in a vast way the data infrastructure business. So these are the three giants who have a very young business. These businesses were only founded 10 years ago, roughly, out of nothing. And these businesses are the growth engines in their internal business mix. And they seem to own the topic of data centers. They seem to own this topic, like Marina has shown it with these hyperscalers, right? That's what they do. It reminds me a little bit of the first computing system in 1945, ENIAC. It was also football fields higher for computer, right? But today a computer is like this, right? So I see no reason why a data center needs to hyperscale, but I'll come to that in a second. But this is kind of what we look at. And we are changing in industry now from the slogan mobile first to AI first, right? That was Sundar Pichai, the Alphabet and Google CEO, at the Google I/O conference in 2017, changing Google basically and saying mobile first is history. It is AI first. And that very trigger, artificial intelligence, and everything behind produces these incredible, amounts of data we are dealing with. Because it's not about only something sequential, store your name and date of birth, etc., but rather have a training base, a lab of something, and train the algorithms of artificial intelligence that they, at the end of the day, can assist us as human beings, right? It is not a dystopian thing. It is actually something which can be quite useful. but the amount of data is key, and the lab you have is key, and that is why also politically it's very critical, right, to fragment data, or to keep the data pools too small, because the truth is China has the biggest data pool on earth today and the biggest lab. And who will win in AI? It is quite logical who will win. The one who has the biggest data pool. And if we in Europe, have in Austria, my home country, the county of Salzburg data pool and the county of Vienna and the county of Styria, that will not work at all, right? So because our healthcare systems will not work and all of the learning does not work. So there's a dramatic evolution undergoing, and the writing is now on the wall where the internet is going. I think all of these words you have seen in a certain context, what they really mean at the end of the time, I think we have not grasped fully. We are only scratching the surface. But of course, we are entering a world of variables, drivables, flyables, right? That is the mobility revolution, but that is also a kind of a second skin. And maybe that is a data center, right, in the future. Who knows? My scarf could be the most effective data center in the future, and I don't need a hyperscaler for that. But that is something which is coming massively and transforming all the infrastructure we have, coupled with also sometimes very conventional innovation with flyables. It's, for instance, interesting, right? Because it's a mix of using computing power, but also new technologies to power, an airplane, for instance. Airbus, interestingly, has a program to be totally carbon neutral as an aircraft manufacturer in 2035. This is only 13 years from here, and they have taken decisions what the fuel is. They're changing all the infrastructure for all airports, but they're also using computing power for things they learn from biomimicry, like birds fly in a formation, right? It is very interesting. So birds fly in a formation, and they use, windshields in that. And Airbus just half a year ago has flown the first time 12 Airbuses across the Atlantic in formation, where the computer controlled the distance, and the energy consumption went down by 27% of these 12 airplanes, just flying like birds, right? And that is a combination of computing and, of course, something learning from biomimicry. So this is all there. Then I think the biggest topic of all, because it's never ending, is augmented reality. Augmented reality is not, what we think today augmented reality is. In the meaning of the word, augmented reality is that we live in the reality, not in the metaverse. We live in reality, and technology assists us. So all the developments of the Google Assistant, and Google clearly is leading the pack with all its research in that regard, they will augment our reality, and in the future we will live in maybe an ambient environment with sensors and actors where there's no phone anymore, and you just say, here in the room at the end of the event, I want to go home, and your taxi driver is outside and knows where home is. You don't even need to say, go to this street or something, because it's just how we live, right? And of course, you need to clarify a lot of questions around privacy and data sovereignty, but we will clearly find solutions for that. I'm not afraid of these things, but that's there. And then there's virtual reality, where you leave your reality and you live somewhere else, maybe in the metaverse. I call it a virtual reality. I am not a big believer in this, I have to say. I think there is a lot of big application areas like gaming, etc. I see this, but I very much doubt that I will lead my life in a virtual reality. Maybe sometimes for a moment, but not, in a majority of, situations. I will live in an augmented reality. And we sometimes casually say AR, VR with a slash. That is a sin. It's the exact opposite. It's AR is just the opposite of VR, right? It is very important also philosophically to grasp that this is very different concepts of society, even if you think about it. Then there is this new buzzword of Web 3.0, a lot of headlines, right? The blockchain seems to be the future. The blockchain is nothing else than a very old-fashioned way of data storing that will maybe be there for a few years, but it's almost like the bookkeeping and accounting under Maria Theresia in Austria in 1760 or something. But of course, it does something in the chain that you can retrieve something. But if this is the end solution for data storage or for database management, I would be wrong, right? This is definitely not the solution for it, but it's a good buzzword for some time. We'll find much better stuff. But the interesting part in there is, of course, the debate about governance in the internet and technology. We'll come to the data center topic here, central versus decentral. What is the role of an institution, of authority, who can run a currency, and all of these experimentations show us that it's, of course, a very open question, right? There's no reason to believe in cryptocurrencies yet. And there's also no reason to already say that central banks would go under. Maybe, you know, the new digital projects of the European Central Bank to launch a digital euro will be much more successful than all these Libra experiments of Meta, which had to be stopped, and all the cryptocurrencies, which in essence today, statistically, for 98% of, you know, their usage actually back crime, drugs, and prostitution. This is what cryptocurrencies do. There's only 1 to 2% of legal use cases for cryptocurrencies, and that is where, you know, avant-garde people like us invest in an NFT or something. But the rest of it is really a very dark, you know, element of the world. But the decentralization is important. And I maybe got it wrong in only saying Internet of Things at the last part. What I mean by that is really the non-consumer side of the internet, right? It is, some people call it Industry 4.0 today, etc. But what I mean is actually when machines are involved. Machines can be huge machines like an Airbus flying over the Atlantic, or simply a sensor or actor which is so miniaturized that we don't see that it's in our clothes or wherever it is. And all these things, sensors and actors, communicate, and they enable supply chain transformations, industrial transformations like in banking, in automotive, and etc. You know what I mean in this. So this is what is happening in terms of the user perspective. And I'd like now to go into the technology perspective when it comes to, you know, data storage technologies. And I'm not a technologist by training, right? I'm just a simple industry participant, but I try to say what I can say about it. I had the privilege actually to work with Ippolito Bestellini, who was talking here, and Rem Koolhaas, who is hopefully known here in Rotterdam, on a very significant data center project, which was never implemented. But it was a project of 2 years where I investigated so deeply like never before, I think, in, you know, technologies of data centers and what to do. And I have taken a few photos of the old books on my table this morning in London. And what is a data center was in there a lot of wires, some blinking lights, rent-a-cops, surveillance cameras, lots of nowhereness, right? That was a description of the data center I found in the book. Then we talked about actually what we had architecturally, the human factory of Louis Kahn for the Olivetti Underwood thing. It was already a modularized system, right, which could scale. It was not a hyperscaler. There was a modular, you know, thinking behind that. It could actually already be sufficient with a single element, and if needed, multiply them, maybe in the same place, but maybe decentralized around. And then, of course, the Gigafactory here in Reno, the automated factory, which Rem has also made a theme in his Guggenheim exhibition, The Future of the Countryside, the Future, where basically these photos, right, from outside Earth have discovered the first time years ago that there are architectural complexes which are partly larger than Manhattan, and not a single architect has ever put a hand on these elements, right? It's crazy that we kind of oversaw it. And then we were asking us a lot of questions. It's basically the contents of one of the books we produced. We produced a lot of books in that project. So how do we want to create a data center? More human, more like a machine, intimidating, like it looks, or should it be welcoming, actually like a bar or a restaurant, right? Could be done organized or free, opaque or transparent, centralized or decentralized, futuristic or nostalgic, right? You could create a very lovely nostalgic data center in that regard. Monofunctional, multifunctional, generic, symbolic. We played with symbolism, you know, in this static, flexible, you can go for it, right? Each of these, you know, antagonisms would be worth maybe a PhD, you know, thesis. It's very, very interesting, and we studied it very dramatically. What we came up with, and it's not for me to go into much detail because I can't also, but what we came up is a very modular data center, a cube basically, a single cube, We worked with engineering to make that cube energy self-sustaining. It was incredible work on the cooling systems, etc., with one of the world's biggest engineering work. You know how storage is organized in that, and the cube, you know, came out like that. And the cube could be scaled or distributed. And then we did one intervention. It was not needed architecturally, but we put in a human spine that also humans are in there, because that was actually really, you know, an arbitrary decision of the architect, human or non-human, right? We could also operate it in an automated way, but I cannot go into this project much further. I just wanted to show you once. Back to the topic now, really to data technology and the question where we will actually store data. Is it here, which I call the edge device of the network, right? It is not in the network, it's at the edge of the network, what we hold in the hand or have in our pocket. Today it could be a phone, in the future it could be all kinds of things. That is the total opposite of the hyperscaler, right? So that could be the data center. Very distributed around the world, even in virtualized, you know, managed infrastructures, we could access these data storage points, right? I could process my data on your device if you give me permission, and I don't have to buy the storage myself, or you would have spare storage space on all your phones. We could compute there. This is what we do today already in a lot of, you know, managed infrastructure. So that's one example. The other one is, of course, you know, scaling servers and racks, what we saw. And there's, of course, still the choice, which is a huge strategic debate. Is this actually in corporate organizational intranets and their proprietary server structure? Lots of companies still think that you cannot move anything in the cloud because they think they can do it so much better than anything in the cloud. You ask yourself, how exactly does the German Chamber of Lawyers have a better data center management than Google, right? But they think for security reasons, they have their own infrastructure, right? So it's a very interesting debate before you then maybe move in the cloud. Hopefully it's as beautiful as Gerhard Richter's clouds and not a tech cloud. That's why I used my German Titan as an artist, right? Gerhard Richter and his cloud paintings are the most wonderful. Or is it actually within us as human beings, right? That is your next presentation on DNA. It's a big one. I can only you know, motivate you to go there because this is a very interesting one. So where will we store it? This is a very interesting debate, and I'd like to give only one hint what could be possible. You could juxtapose what I just said on that slide with this one here, and that is the real core slide, kind of the presentation, me not being a technologist, but I try to explain that. So what are the data storage technologies today and in the future? Today, it is of course very clear that we have a physical manifestation of data centers, which we see with our architectural eye maybe. But what happens within it is a virtualization of operating systems, right? We are not anymore in a vertical integration where an application sits on an operating system, sits on a machine and has a connection. That's how we, you know, operated technology 20, 30, 40 years ago. So all these layers have been broken, and you can store something in a totally different place than operate it, right? And your operating system applications can be anywhere. Like we have an application in our phone which is actually hosted maybe in China, maybe in, you know, wherever it is, in Frankfurt in Europe or somewhere in Virginia in the US. So it is totally virtualized already. It is more and more cloud integrated. Roughly 22% is in the cloud today. That's interesting. I thought it's a low number. I thought it was much more, but it's a slow process that things, you know, move into the cloud. It is containerized, and that is a software container mechanic that you can actually spin up, you know, kind of virtual containers wherever you want, and has scale-out architectures, which mean you can scale it like you want. I run a tech company, and we have just launched a new kind of contextual internet platform called Love in the US and in Asia. And when we want to spin up servers, my CTO and their team, they do it in 5 minutes, right? They spin up servers how they want it. If there would be a user intake of an unexpected million users, servers spin up themselves, they mirror themselves, They find their paths through the internet, through the data centers, wherever they are, and we have no idea whether that is in a hyperscaler, in a shared infrastructure on UPCs at home, could be, because we have providers like that, or actually on things. So this is what we have today, and that is totally standardized, and it's growing, and it's growing, and growing. And actually, it's a very efficient mechanic, because if you think about these data centers, and also from an environmental and sustainability perspective, the data centers Amazon, for instance, operates run at an 80% utilization of the capacity. The data centers of companies run sometimes at 20 and 30%. So you're wasting energy like crazy if it's not yet in the cloud. And moving all of that in the cloud will bring down these numbers, because data centers indeed, I know the number basically in a country ranking of the world, would be the 4th largest country in energy consumption in the world today, right? Number 4 already in terms of energy consumption. And these crazy old techniques of blockchain, of course, add to that. Thank God some of the crypto providers have found a bit better systems where they now come down by 90%, which can only be a beginning, because that paradigm is just so weak, right? Which we hear from there, and it needs to change to be more energy efficient. But where now the labs are experimenting for data centers is on the right-hand side of that slide. So there's some incremental improvements of data storage. We're talking about data storage, how you can become more efficient and then just more flexible. With helium-filled hard drives, you just fill it with helium, and then with air, and then the disk can rotate more undisturbedly, and you now have 10 terabit hard drives, which can easily be produced already, and that is scaling and scaling and scaling. There's something called shingled magnetic recording. A shingle is a roof, right, in Austria on a hut, where they just compress these circuits on a disk, and they have a certain technique to just scale the way they do data storage. They have non-volatile RAMs, which is sitting on bus systems in a computer. It is extremely efficient in storing data between the bus and putting it back and front, and with that it's producing a huge scale advantage. Then you have rack scale design, which is, it's not a rack, but it's ideally looks like a rack, where you put things together, like basically the storage unit, the computing unit, and you really work on the connection between these things, and you win in the connection. That, by the way, besides storage capacity, is the other element. Bandwidth in networks, of course, is exploding. We always talk about Moore's law in computing devices with the 18 months doubling, but there's also Metcalfe's law with bandwidth tripling every year. So if basically the pipes grow faster than the computing power, what do you do with the data? You don't need to keep it central anymore. You can actually shoot it around like you want if the bandwidth is faster, right? Like all of these elements. So that's interesting. Optical storage is an interesting one. There is a burning of with lasers on basically glass. The point here is the sustainability of data that lives 1,000 years or 2,000 years, whilst data is kind of endangered in another context. But I really want to talk just 5 sentences about your next topic in the next thing, and that is DNA storage. Of course, in a molecule, and you know how it works in the mitochondria with the DNA, information is stored about your genome and all the chromosomes, etc. And you can store information in a molecule, right? That's clear. It's rather hard to get the information in and out to date. So this is the big barrier. But 2012, Harvard University was the first to be successful in storing actually a book with 53,400 words, 11 JPEG files, and a piece of Java code in one molecule of DNA. So that was 10 years ago. Of course, we are much faster today. If I give you 2 numbers, one molecule of DNA can store 2.2 petabyte of data. We don't know what petabyte is. I say it differently to you. A teaspoon of DNA can store the entire data of the world. A single teaspoon. One. The entire data we have in the world today on a teaspoon. Now, if the technology advances in bringing in and out, read and write, you say in computing, right, into storage, that this becomes more cost efficient, we basically can run around with billions of times the knowledge of the world in our bodies again. We can bring it kind of back in a decentral medium. There's no need for storing data anywhere else because you kind of become consistent again as a human being because you can carry everything, right? If already the teaspoon carries the entire knowledge of the world, think about, where we were thousands of years ago and then Gutenberg with the book and the technological revolution, and now somebody says on the teaspoon of DNA, you get in the entire information of the world today. And if this is industrialized as a technology, right, there is a never-ending story to data storage technologies. My last slide is on the societal perspective. And we need to look through our children's eyes, right? What world we want to live in, that is for sure clear, because technology is always friend and foe. This is very clear. It is our decision, our way of coping with it, trying to educate ourselves, trying to master the technologies and trying to deploy it in a dignified way, that we get this right. And the societal perspective on that, for me, is two elements very much. And that has to do with the future architecture of the internet, like, for instance, W3C is propagating, etc. The one is really around privacy. This is a human right. There is no doubt. Privacy is a human right, and it cannot be compromised by anybody. And the design and architecture of the internet today is the exact opposite, right? It is designed to centralize data in the hands of a few without any control and knowledge of the user and about any consciousness. So this needs to be turned around, and that is why the only buzzword from Web 3.0, which I love, is decentralization. And if we could store critical data, it's not all data, right? But when it becomes personal, my data, as Christopher Schlaeffer, close to where I stand now, maybe even in me, like it could be possible. And all the applications out there would have to ask for permission to use that data, but not suck it out and keep it there. But the personal data is kept here, and applications can still work. That is kind of the architectures for the future internet, which are currently being discussed by all the, governing bodies out there. I think that is the world I would at least like to live in. Thank you.
Wow. I'm so glad that you're here because, you're clearly so knowledgeable about all these topics. We are just trying to catch up. I have many questions, but I know you too, and also Victor Munoz is going to give a response. I want to maybe ask you only two questions for now. One is a clarification. What do you mean by the cloud? Because we are talking about data centers and then the cloud. What is that we call the cloud?
I think it is really what we understand by what we see today offered by Amazon, Google, and Microsoft, right? Servers in the cloud, somewhere else, not under control of a user or a corporate user, and you just, rent out computing infrastructure. That could be simply server infrastructure, application management, etc. That's the cloud for me.
And is that manifesting either hyperscaler data centers
or distributed
data centers.
infrastructure.
And when we actually have our files in the cloud, we don't know exactly where those are. No.
No.
Yeah. And the second question is, at some point in the presentation, you said, "I'm not scared," or "I'm not worried." And my question will be, is there anything about these developments that concerns you or worries you about the possibility of developments in digital infrastructure or the Internet of Things?
Totally right. I think I was not shy in hinting at that. I totally disagree with the notion of a metaverse. I have a real problem with that. Right? For me, this is a fake world. From an ethical point of view, right? I don't want to live in my fake home and operate in a fake world, right, where I cannot be on my own sofa anymore, but everything looks like, painted like in a Nordic Scandinavian design. We saw all these presentations, right, which came out from Meta. It's ridiculous, such a concept, and we need to be really mindful that we don't lose touch with reality in that regard. So I'm skeptical on that. I'm skeptical on a lot of things. However, and that's why I turn it around, it is us as human beings in this society who have to step up, right, in trying to create that future we want to live in. And we have so many structural failures, right, regulation, legislation, etc. Politicians, and I'm a very political person, I'm not a politician basher, not at all, but they need to step up to understand this phenomena, right? Regulatory bodies need to be able to regulate financial currencies out there which are digital or metaverse, etc. It cannot be that 15 years after the fact, the regulator comes in and has to break up a company because for 15 years we've been blind and looking at something and it has been too strong or grown in the wrong direction. So there needs to be a balance in our society. And I think something like here is exactly the right start, because I guess you are very much the people equipped with the intellectual capability to challenge just that from the beginning, but not in a way to be negative on technology. This is the wrong approach. Technology is something wonderful, it can be something wonderful, let's say, but we need to shape it in that direction.
Thank you. So I want to invite Victor Muñoz-Sanz. He's an assistant professor in TU Delft, and he has been conducting over the last many years, a lot of work on digital infrastructures, and in particular in connection automation. No, please. So Victor, please come here. And we invited Victor to give a response.
Well, then Well, I thought I would be sitting there, but it's okay. Well, thank you for the presentation. It was amazing, and indeed I learned a lot. And indeed you can look optimistically, but also there are some things that I want to go in depth with you, also taking advantage that you're a philosopher, which is very interesting. But maybe we can go, as a first question, a more direct one about the metaverse question, which also is the topic as well of Marina. Marina, last time you finalized your first lecture saying something about that the implications of this data technology in terms of data consumption and even effects on communities and on the use of energy and all that, is important because in the end it's about the planet we share, When I see the developments of the metaverse, in which indeed it's about escaping reality, I have doubts of whether we share the same planet, that some people are actually already planning the next step in which, okay, we just forget about the real and just kind of get into the metaverse, and that's the new world in which we exchange, consume, and live. No? You say you don't agree with that view, you don't like that view, and probably many of us also share that opinion. But could you maybe explain or elaborate on why do you think a company like Meta and others are pushing so much that concept? What are they investing so much in that?
Yeah, well, I need to, as I'm also working in that industry, right, I usually should not say or qualify a competitor, etc. And I'm indeed also competing with Meta versus assets, especially on the communication side. But first of all, a single company cannot explain something actually not so well, and then the whole world thinks that this is the great new thing. We need to be a bit more critical in reception also. I actually don't understand why the whole technology community, in a majority, talks about the metaverse without any criticism or critical attitude, like a journalist would do, etc. So let's think it through and then single out what use cases are there for virtual reality. Gaming is one of them, right? I want to consciously be in a virtual reality because I travel time to the Middle Ages, right? Because there's something going on I want to participate in, or in the future. So that's legitimate. Like the movies were always legitimate as an art form. That is all good, right? So that's important. But when it then comes to in a very uncontrolled way, presenting a business. We have many rules around businesses, right? In some countries you need to be registered, you need to be credible, etc. Now in Horizon you can set up a shop, which is the most beautiful shop on earth, right? Maybe nothing is there to buy, it's all faked. This is a world, I think it will not happen like that. Let me say that. It will not happen on that big scale. There's much bigger topics in the internet. And I've pointed out which of these are from my point of view.
Then about of course we are encroaching into next session, but I think DNA is quite a powerful presentation you did about almost like what if we become the cloud, no? We kind of hold the cloud. Which of course opens very interesting, trees are connected through roots into the kind of a wood-wide net, no? So can humans in a way become close enough through DNA and also connect to the data, no? But then I wonder if you could also maybe elaborate a bit on the ethical implications of that in terms of what happens in terms of when that's not accessible to everybody, and if let's say on top of ideas of race and genes, an additional layer of data and knowledge is embedded in our bodies, and how can also lead to some kind of distinctions in society. And also, what about ownership, and I want to get your data, what do I do with you,
Series of good questions.
Yeah. And then also if data is based on us, which we don't live forever, how do we deal with that?
Yeah, very good questions, and have for sure no good answers to that. But let me give it a try from basically just brainstorming a bit out. First of all, DNA as a storage facility has to be, first of all, seen independent of us as human beings. It could be on a bacterium, right, or a piece of DNA somewhere. So that would be the distant view, right, and separating the human from that data storage medium. That is the first space, and that will be powerful. And as I said, the read and write mechanism is still not mastered in a cost-effective way. It's way too ineffective to write something and read it out of the DNA. That is not, like we could use it today fully at scale. So that has to be solved, but it will be solved. If it then would really be the notion of being us ourselves and our DNA, I would still say this is a data storage facility, and you could kind of isolate questions of data sovereignty, privacy, ownership from that. You could even carry somebody else's data if that other person asked you for, right? And say, could you store my, what the heck, right? My years from 17 to 24, because I don't want to carry them. I'm traumatized, right? These 7 years, please. They were not good for me. So you could carry them. That would be there. And then you take a computing analogon. Of course, data storage is not the complete equation, because it's also about processing power, and whether this processing power up there could actually interact with all the world's knowledge on a teaspoon inside you or not, right? And there's all kinds of very, very interesting questions, which are human questions, but sometimes also go further beyond. Just if I may, in a minute, there's this American AI artist Ian Chen with his fantastic artworks, and what he did 4 years ago in the Serpentine Galleries in London, he created something named Bob, a bag of beliefs. It was a creature living on a canvas. The canvas was not a canvas for oil paintings, but it was actually a screen in the Serpentine. He gave birth to 6 of these Bobs, 6 canvases, who lived in the gallery for 8 weeks. It was an incredible computing, thing. And Bob looked a bit like a double helix, aesthetically interesting, and he could interact with the audience, so the visitors of the exhibition. So if I would pass by and smile at Bob, he would compute that. Somebody else would scream at him. He would compute that and compute all the time all these interactions. And the artist called the differential between the experience me smiling and you screaming at Bob building a consciousness. 2 out of the 6 Bobs died of depression. during the 6 weeks. They also had a metabolism like the Tamagotchis of the 1980s. In Japan, they had to be fed, so they could also be dying of, and 4 lived happily, and they could be scaled, and there's now a life after Bob. It went to the Luma Foundation in Halle. It's now at Light Art Space in Berlin. But what you see here is that a creature has been created who does also the processing, right? So we'll have very interesting debates around that.
That's interesting because indeed, if you say that it's about, it's not maybe us, but it's putting data on other beings, like bacteria, or one can imagine already a new typology of productive landscapes in which is like just farms of data with beings which are just there holding our data, no? Which is quite also, I guess, risky in some aspects. If there's a virus that comes into play, and then the whole data is erased, no, because it already died. Okay. Yes. So, Marina. No. I mean, we could talk for hours, I guess.
Okay. No, thank you so much. An applause for Victor and Christopher. And now is your turn. So I guess, yeah, you were very quick. There are questions. So yeah.
I don't have to see. No. Okay. I just had a question about Neuralink. This new, well, it's not new, but actually Tesla is working on Neuralink right now. This is chip to connect the human brain with machine, the system, basically what we are talking about, what you have shared. And actually the original founder went up on his own and did something else that is now developing also. But what do you think about this? Could this also be, like, how will this be related to this augmented reality? What is the potential? I know it could be for health reasons, for people with paralysis or other problems, but what other future potential do you see in a technology like this?
It's also a very good question. I'm not so familiar with Neuralink's findings itself, but I've talked to a few brain researchers about technologies like this. These are interfacing technologies, which basically break the human interface with a machine and do it differently. They were very much coming from the angle of helping, unhealthy or handicapped people with things, blind people to imagine a tree was a use case, right? And that was successfully done, that somebody could be kind of projected in, or I don't even know how you say that, the imagination of a tree and how it looked like and everything, so that was working. These were sometimes technologies which were rather brutal on humans, but they're getting less and less invasive and more subtle. So I think it has to play a role from that angle. But you are for sure asking the question, what does it do then in usual life, and how far could that go? I actually have a hard time to even imagining how far that goes and what ethical questions come up. It's very interesting in that regard. And that is what I would like to say, is that how we govern our societies going forward, right? And our political bodies often being incapable. We have across Europe, in most countries, now something like ethics commissions consulting governments. And usually if you look at these ethics commissions, you'll find the most impressive people there from all walks of life, architects, technologists, scientists, etc. And they operate on a level, so if you are interested in themes like that, I can only recommend to follow what is published there in these ethics commissions, because I think at the moment there is kind of the highest quality of research output, and then embedded in the ethical debate, which is so interesting, and I think that swings in your question, right? Yeah.
Yeah.
I have a question for you and Marina both, or you may choose who answers it. It seems to me that the whole story of data is completely wound up with growth, with the story of continuous growth. And there's a paradigm of growth that is presented to us nearly as if it were natural law, with Metcalfe's law and Moore's law, and everything is about growth, growth, growth. And it reminds me a lot about how still also in economy, the dominant paradigm is that of growth. if we do not grow, we die, is what people would have us believe. But there's also an alternative economic views right now, which talk about the post-growth society, which we could translate or imagine how we translate into our lives. Is there also, an off-ramp for the growth of data, where we might be very careful with the amount of data that we produce, that we start editing again, because we have only so much data that we want to spend? Is there a decrease scenario for data?
I can also.
Well, I have my own personal position about that, but I'm interested in listening to you first.
Okay, I'm thrown into the fire. If you heard me speak in the very beginning, I already talked about so much garbage being produced in data, right, which can only be thrown away, and we need to be more economical about that in our principles. There should be a certain frugality around that even, right? And I think, first of all, you don't need to store all the data because it's such garbage, but just the meaningful data or some aggregate of data on which you can build something on. Just, churning data into systems, which we do today, is meaningless in a certain way. So I totally believe in its own dimension into, being different with data. It's even interesting, and you can think of Apple what you want at the end of the day, but they have that in their terms to be economical with user data, so that they constantly challenge themselves what really needs to be stored, right? And that is a very interesting paradigm you would never read in Meta's terms and conditions, because they just would take whatever they get, right? Because you could make something out of it. And there is these are governance decisions we can take at the end of the day. And then, of course, also technology will be interesting, right, in terms of compressing that. But there is, I would say, still an underlying growth trajectory in technology, which we cannot deny, because it is, in a way, the most powerful source of progress, right? Hito Steil, the German artist, said, "I see 3 angels dancing on a needle. The first were the arts, the real source of change in society. Second was science, a rather young discipline. We have it since Pascal. And the third one now is technology, and it is not in the trajectory where it's falling yet."
Yeah, I totally agree. I think at the end of the last event, we were thinking about the possible relation between heritage and preservation and data. And I will be very interested in bringing these different disciplines together to think about what's on a kind of a societal level, what should be preserved, what data should stay or should go, and also have some sort of data literacy to say, yeah, I have to be more aware of the consequences of hoarding data, that for instance I do. The same as was saying last time, perhaps before we had the tap water open while we were washing dishes or brushing our teeth, and now we are much more aware. We see it in the hotels and everywhere, like to be more mindful about, the resources that we are spending. And with data, we had the sense of limitless and unlimited capacity. And I think that now we are much more aware that that's not the case, or at least that has consequences. But I think it's both at the level of companies, but also at the level of individuals, how to relate to data. And having these conversations, I think it's important to be aware of how much, emissions have cost one email or one selfie, and not to put the blame on our selfies, but in a way to be aware of that. But I think it's at the level of society. The problem is, I would say that data is money. Accumulating data for future use that we don't know yet what it might be for, but still, we know that hold the data. We have more powerful data sets, and that can be leveraged in the future. So we know that accumulating data maybe is very profitable for the future. So I think that also prevents, in a way, to have a more honest conversation about deleting, degrading, degrowthing in relation to the digital and data. More questions, perhaps? Yeah, Sophia.
Question about architecture. pertains to the. I have a question about architecture because it also relates here to the ideas around growth or degrowth. From what I understand, your research, Marina, is based on the architecture of these data centers that exist underwater or in the north where it's cold, because it has a relationship, or you're interested in climate change and the impact of the present and perhaps future more environmentally aware designs. What does happen, and maybe the question will be responded in the next lecture, but I was very surprised about the teaspoon of data of the world. And so if that is in fact, if we go through a kind of molecular archive, then what happens to architecture? Is it that we do not need it? Would the archive of the molecule, the repository of that, really be a body or a test tube in some, I don't know, with a key that someone throws to the sea and then no one finds it and can open it? I mean, or they throw it, is it a Rosetta Stone that they throw out there in the universe and wait for someone to find it? So what is really the relationship of architecture and events to our investigation of space, if it is indeed the molecule? Because if we could put the data there, why don't we put the International Space Station inside and throw it out? Or maybe that's happening and I don't know. So it's not about the virtual reality. It's just about it's the anti-growth, not like the millimetric space. So
yeah, I think it's a fantastic question, and all the examples that you presented are possible within that development. For people like me who understand architecture beyond the building, so architecture is building, but it's also more than that, like the infrastructures, the relations, the conditions that make architecture happen and the space happen. We contemplate the different scales at which the architectural act operate, and some of them are molecular because we are interested in the quality of air that have our spaces. For now we have an open window. So from like the toxicity of the materials that those architectures are made of to how they connect to other architectures. So indeed, I'm not going to say something that hasn't been said before, like the Ames Powers of 10 movie that you see how, you go from almost like the minimal scale to the cosmos, no? And perhaps it's very arrogant from the point of view of architects to say that we can operate across those scales, but at the end of the day, everyone will decide on where is the area of expertise. Maybe some of them decide that they are architects of the molecular, and they see how, create interactions or make interactions between different cells. So obviously that's very, involves that the way in which we conceive architecture and we study the architecture is different, but why not? So, but I mean, for me, what is interesting is that, especially in the data centers, perhaps the more banal aspect is the shell that contains the servers. And that's why we think that architecture has to be redefined when we think about data centers, because otherwise we end up only defining or designing an envelope, the facade that looks beautiful or funny, or the typology that is only like horizontal or vertical. But there are much more, and I think the cases in which you decide to connect a data center with a housing development, or you take into account how a series of data centers affect ecosystems of communities, that is also architecture. But yeah, I think it's exciting, terrifying, all at the same time, and I don't have the response, but I think that's probably that will be developments that we will see in the next years. To add something?
I think I'm only reminded this discussion of the one word actually Rem brought on this page. It's ephemeral, right? Maybe we need to design the data centers as ephemeral, that in 30 years they have to go away again. It's it's maybe very similar to the switching centers of telecoms companies. They were usually in city centers, and you had all these switches. They were big, like a school, right? And now the whole technology is just one box like that, a switch from Cisco, and all telecoms operators have to sell off these real estates. They are gigantic real estate owners. So hopefully in the data center, transition, evolution, that doesn't happen. It's more ephemeral or flexible vis-a-vis different scenarios.
Yeah, I totally recommend the work of Julia Velkova, and she is Swedish and writes about data centers from the point of view of energy thermodynamics. Very interesting, but also about this obsolescence, because we always imagine infrastructure as it's going to last forever, but then it's exactly what you say. Not only data centers, in some cases, are using bunkers because they have the right conditions for temperature or existing infrastructures, but probably they will be obsolete. So, Sophia, maybe the next Meli is in a data center because, it gets emptied of servers and suddenly it's a very interesting real estate to do contemporary art, as has happened with factories in the past, the industrial. So maybe, yeah.
I had one question, because you, in the beginning of your presentation, you were talking also about how the development of computing power has influenced also the creation of data. And there's, of course, and you talked about the big trends, and one of the big trends or big promises is also the quantum computer. Yeah. And I don't know much about it, but I was just wondering, what is the impact of if something like that, with that type of computing power, would happen or would be reality on a bigger scale? What would happen with the data production? Will that decrease or increase, or I don't know.
I think it's open, because the two of you have asked complementary questions. You can process much faster and still not store all the data, right? So you have to, and the quantum computing is a computing or processing, technology. You have always to have a look at that triangle, which is processing, storing, and transmitting in the network, right? And how powerful is that triangle? And that basically are the three input parameters for the design of this ecosystem, right? Is the network so fast that you can basically shoot everything from here to there in a nanosecond with that small latency when it comes to autonomous driving, for instance, right? Can actually a server in Virginia drive your car in Rotterdam, or is that too far away and you need some edge computing or some intelligence in the car? So the design of these ecosystems is very, reliant on all three variables in here. But there's no doubt that all three variables explode in kind of capacity. We know it from Moore's law, but also in the networks and in the storage, right? At the moment, we see no boundaries. That's why I think, Marina, this gap which could emerge, let's see, right? Whether there will ever be a gap. At the moment, I don't see, if you think about something like DNA, that there is an end of what we can imagine at the moment, and this plays together.
Well, thank you. This is a question for you, Marina. So I think it was clear Christopher's posture towards how he's skeptic about the future of the metaverse. But my question is, what do you think about the future of the metaverse, and what's your posture? Because I could assume that if you are thinking about where to store it in the future, is because you have a different perspective and you think maybe we'll grow, or I don't know. What's your perspective and what's your posture towards the future of the metaverse?
I think I very much agree with Christopher. I don't imagine myself using the metaverse. It's not the reality or the world I would like to see. I see it as a form of escapism, but very problematic escapism. Because I think at the end of the day, we all inhabit different worlds when we are reading a novel or watching a movie, or, there are many ways in which we are constantly, even sleeping, inhabiting virtual realities. But this one in particular is extremely problematic. It's very also the way in which it's used. As Christopher says, there's no regulation, brings the worst of many of the human relations, and is actually very polluting in many different ways. So I'm not a fan of this idea of the metaverse. What I find intriguing is to have a realm where to perform or, try different ways of being in the world. And I see that probably many people is interested in inhabiting the metaverse to become something else, or someone else, or perform other lives, perform other ways of relating or being or feeling or looking. And that thing, I imagine, that is needed. So what could be another arena where we feel the possibility of becoming other and being other and testing these identity shifts, these different ways? That thing, I think, is relevant. But I don't think that what Facebook or Meta proposes is the way to go. So I generally try to not to enter in this kind of convoluted space of the metaverse. In this particular research, my question is, okay, whatever you think the metaverse is, the thing, you think whatever, but how do you store it? How does it work? Who is maintaining it? How much it is consuming? How that it doesn't depend on opening new mines or creating more data centers? So that's my question. How do you do it? And is there any way to perform the metaverse in a different way? Because it has some interest, that's why people is triggered or interested by it. But yeah, for me, I am not gonna wear the Googles soon. Yes.
Maybe I have a question about the AI and the artificial intelligence side of things. As you mentioned, Facebook and Metaverse, Meta, collecting all sorts of data. It's no longer visual or anything. It's about our lives as they are. It's living data in that sense. And we see a trend of machine learning and what it's capable of doing, just to scratch the very, very surface, the buzzwords Midjourney or even DALL-E, the kind of synthesis that this data can create. These are essentially machines that were created to create other machines that the creators no longer understand how do they operate. That's a scary concept in itself. But then you let these machines loose on sites like DeviantArt or Pinterest or any visual arts in this particular case, and the outcome of this is some art that's no longer property of anyone, but it's a synthesis of the many. So if you were to do the same with algorithms on this other data that Meta is collecting, what kind of a future could we end up with? Is there any thoughts on this idea?
Well, I don't know. This is such a complex question. What I just know is that we need a very practical debate on how we enter this game, right, as users. And I don't want to be asked as a user once when I onboard a system like Instagram or whatever it is, wants to say yes to terms and conditions, not reading what is in these terms and conditions, and then for a lifetime my data is collected and have no clue what is happening. I want to be asked actually on a transactional basis. With every single step I take, I want to be asked again as a user, and it does not need to be very bureaucratic, but I want to be asked. If something happens with my data which is not agreed upon consciously by me, right? And I think these regimes, we have that big debate at the moment between Apple and all the advertisers, because Apple is tougher on that game and cuts off possibilities of advertising, and revenue streams of Meta and Snapchat have of course really been hurt by that. But this discussion is really necessary, right? Because it cannot be that I've once given a signature and 70 years later I'm part of an experiment somewhere. And that is our reality in the internet at the moment, right? We are not asked in that practical way. And what I as a user want is such a system that whatever we could now together imagine from your question should never happen.
Okay, one more question, and then I reserve one for myself. Oh, two, okay. Great. Simon and Arthur.
Thank you. You said something about politics having to up their game, whereby I assume you mean national governments. My question is very simple about who regulates this. Is it academia? Is it business?
Yeah, it is a really good question, right? And there is now, of course, on the European level, at least an attempt to regulate in some dimensions, right? With some privacy regulations, Europe has been really a leader and things are copied like that. But if you ask the question of cryptocurrencies, we are totally lost in the world, right? To actually regulate something like that. Governments now start to launch their own projects in competition, as opposed to, you know, stepping in somewhere. And this is a very good question. The traditional bodies are, you know, the FCC in the US, who does very much telecoms regulations, competitive law, right, breaking up companies if a relative market share goes too high. That was the AT&T case of the 1980s, producing all these regional Bell operating companies, which then reunited 20, 30 years ago. So AT&T never went away, but it split up. But this is a very good question, and we need to, on all levels, regulate.
Okay, in fact, I have a difficult version of the same question. Jürgen Habermas has posed the thesis that we are witnessing a process of colonization of the life world by the system, Lebenswelt und System. The system are the state, the market sector, the life world are the individual, but not the isolated individual, but the individual as a member of communities and social groups. And I think that, I was wondering whether we were discussing a very individualized conception of data, and should also think about how to handle the question of ownership of data, which can be seen as the property of a community. And that, well, this is enough for philosophizing, but is the DNA storage, I think, is a very individualized instrument of data storage. Can you say something more about the, let's say, the logic of the other technologies, new technologies, in terms of how they can handle the question of community ownership of data?
It's an entirely different debate, of course, but a very relevant debate. You could even draw an analogon from the topic of open sourcing things, right? What you had in computer code, right? We come from a world mentally where everything had been patented, and you lived on a patent as a pharmaceutical company for 15 years, you could make money, etc. But in computing, this is going in different ways, right? There's some proprietary ecosystems, pieces of software, and there's open source software and open source data, of course, also, right? And I think this has a huge legitimacy, the open source movement and idea, because in terms of, from an innovation management perspective, if you are academic around it, an open innovation system requires exactly that. You cannot compartmentalize, data and own it here and own it there, because you lose all this cross-fertilization, and sometimes data, think about, in diseases, etc., requires really that something is more broadly owned, open source, not owned by one company, one patient, one hospital. But then, of course, the tool in the middle of that is often anonymization of personal data, which we have to have in that equation. But I think that mental construct of open sourcing could be an interesting opener in such a debate which you are triggering here. Yeah.
One more.
Hi, thank you for your talk. I was wondering if you could talk just briefly on sort of determining individual identity, or like this being something within the internet that I think we're seeing now, having sort of issues with anonymity on social media and these sort of things, but particularly when it comes to the storage of individual personal information. How will we work with actually knowing who's who when they're activating, or when they are getting that information or accessing, is what I meant to say. Thank you.
We have no legal framework for identification. Today I can be Maxi7 with a username on every kind of platform, right, with an avatar picture. And there is no regulation on that, right? There are some approaches, for instance, in the good old telecoms industry, especially in emerging markets, where you can only get a SIM card with a passport, right? And that is sometimes an element of, that could be in Pakistan or India. If you look at countries like that, you really need to identify. You cannot pass on a SIM card to somebody else. So there's an angle to come via that identifier. But I think we have to have this debate, because that is a personal note again. I want to live in an internet where I can identify somebody. It's of course the best, also weapon against hate speech and anonymous and all the repercussions which are so negative from social media, which we cannot master and lead to tens of thousands of people watching these videos inside YouTube and not mastering it because the algorithms are still not good enough, right, to get all that shit, pardon me, out of the system and crime and human rights abuse and whatever we have. So it's a big thing. Visual, I think, is an interesting one, right? Because computer vision, identifying, we have it, right, looking into something could be a very powerful thing that is mastered in a privacy compliant way. But it's a huge debate. I'm all for it, right? As also for the question in social media, whether actually the platform has to take content responsibility and not always say, well, this is the user's content, I cannot do anything, right? The immediate SARS of the past, they had to take, content responsibility, what their journalists would publish on a platform. And now we have media platforms where those monetizing so brutally and owning all that have zero responsibility what is operated there, right? And of course we need free speech and all of that, right? But there is a big debate in media regulation to be held.
So I have the last question. And so we saw you in this image presenting the iPhone. And I wonder, there was anything that you know now that you would have known back then?
Oh, there would be so many things. I cannot tell you how many mistakes I made in my life. So, no, there's a lot. There's a lot. I think life is about growing, right, as a human being and getting stronger as a person and father, friend, and also as an entrepreneur in my case of that. I'm constantly learning and I'm so far away from doing it well.
Well, you did very well, it seems. So I want to thank you once more for your generosity and sharing all your knowledge with us and being so open to discuss questions ranging from DNA to privacy, individuality, and all in between. It has been really a pleasure to have you here. So thank you so much.